Hello, welcome to Chapter 4.4, Part 1, Solving Linear Inequalities in One Variable, Introduction. Inequality symbols. These are some symbols that you may see. Not equal to is an equal sign with a slash through it. This is less than. This is greater than. This is less than or equal to, meaning it's not just less than, but it's also equal to. Summary of interval notation, inequality notation, and their graphs. So, in this particular table, it shows what an open interval is and how we would write it in what's called set builder notation. So, an open interval would be these little round brackets. A closed interval would be square brackets. A half open interval will have a square and a round bracket, etc. We'll go into examples that will show what these mean and how to use it. There are two different types of notation that we're going to use. We're going to use something called set builder notation. That's the one with the squiggly brackets. And the other one is called interval notation. And intervals are a portion of the real line often expressed in interval notation. For example, an interval with round brackets, in this example 2, 9, is an open interval where 2 and 9 are not included in the set. In this example, we use square brackets for 1, 7. This is a closed interval and it includes all the real numbers from 1 to 7 that also include 1 and 7. Here we have a square bracket and a round bracket. This is called a half open or half closed interval. The set includes -5, the one where the square bracket is closest to, but doesn't contain 5, the one where the round bracket is closest to. Now let's graph some intervals. So in A, we have the interval -5 to infinity, or in set builder notation, curly bracket x, where -5 is less than x, close curly bracket. So how would we draw this on a number line? Well, first we draw our number line here, and then we put in our interval. And we see our interval starts at -5 and goes to infinity here, or you can say that -5 is less than x, where x will be everything else along the line. And then finally, I close this or start this with rounded parentheses indicating that the number is not included in the solution set. In example B, I have round bracket -infinity 7 square bracket, or in set builder notation, it would be curly bracket x, where x is less than or equal to 7, close curly bracket. Notice on any time when I have an infinity sign, it's always a round bracket, whether it's positive infinity or negative infinity, because you can never end infinity. It'll always go on and on and on forever. And infinity is not a number that is inclusive. So let us draw this line. So here we start at 7, but it's less than 7, so we draw the arrow going this way, meaning it gets smaller and smaller, and that means negative infinity. It'll be everything going on and on and on forever, getting smaller and smaller and smaller, but we include the 7 because it's less than or equal to, and we have a square bracket here, so I put a square bracket on my graph, which indicates that the number is included in the solution set. In example C, I have in the interval notation round bracket 2, 15, close round bracket, or in set builder notation, I have curly bracket x where 2 is less than x and x is less than 15. So how would we write this one? Well, that will be just an interval inside because x will be between 2 and 15. So this means x is between 2 and 15, but does not include 2 or 15. In example D, we have square bracket minus 4, 3, round bracket, or in set builder notation, x, where negative 4 is less than or equal to x, which is less than 3, curly bracket. So here's how we would draw this one. Well, it's an interval, and we can see that easily in the set builder notation, and here's how we would see it in the interval notation. Here is negative 4, but it will include negative 4, and then we will go all the way through to 3, but it will not include 3. Thank you very much. I hope that you enjoyed this video. Take care, be well, and goodbye for now.